to be more fabulous, because science is not fabulous enough, in my opinion. So please go absolutely wild and give her all the love in the world for Chromatik!
Hello. You'll have to bear with me while I figure out the equipment. So, I am Chromatik, and I am here to tell you about the physics of fabulousness. How we can all learn from birds, butterflies, and monkeys about how to use light to make ourselves just that little bit better. But I see you thinking, how can anybody look this good in a dress and know physics? It turns out that those skills are unrelated. But I do have an origin story and I do have qualifications. This is true. My mother was a beauty queen. My daddy was a physicist. I was bitten by a radioactive butterfly. Then my mother left the one-horse town that she'd managed to become the beauty queen of. My daddy got made redundant in a series of swinging cuts on science investment, and I had a bit of a disagreement with the butterfly and crushed it before it could teach me how to use my powers of flapping and sugar drinking to fight crime. So now I just fight dowdiness. And now we will look at optics, the science of light, and how you can make oscillating electrical and magnetic fields work for you. There will be a slight pause while the technology catches up with what I am doing. Are we going to slide through to the next slide? Yes, this is a wave. Light is a wave. It's Thursday for those of you who've had a hard week. This is what a wave looks like. It looks like that. It looks like my hair. And if two waves are in the same place at the same time, then their powers combine in a way that is not dissimilar to an 80s cartoon that I am far too young to remember and the clicker is still too slow, so that visual joke isn't working. Imagine there is a visual joke here. Imagine there is a diagram. There, powers combine! 80s reference, you're all older than you look. Flattery. So when you have two waves and they come together, they can come together so that the peaks line up with the peaks, and they make bigger peaks, and the troughs line up with the troughs, and they make bigger troughs. And that we call constructive interference, and there will be a diagram of it any minute now. There we go. This is constructive interference. This is destructive interference, where the peaks meet the troughs meet the peaks. Everything cancels out, you get nothing. This is a gift from Wikipedia if you wish to watch it later. And so, let's see how these constructive and destructive interference is used in nature. This is a picture of a starling and some ham. I would like to thank the person who took a photo of some shiny ham and put it on Flickr under a Creative Commons license. And these things are iridescent, much like my... That happened. It's Martin Huygens. No, Kirill Ignatieff. So these things are iridescent. They shine different colours when you look at them from different angles, and this is because of constructive and destructive interference. Because these things have a small layer on top of them. And, I figured it out, I've got to point you in the right direction. So if the light that bounces off the top and the light that bounces off the bottom are aligned by the time they come back together, then you get constructive interference and you see a colour. If they're not aligned, you get destructive interference and you see nothing. And the one that bounces off the bottom, whether or not it's aligned, depends on whether or not the path it takes has enough space to fit whole waves in. If it only fits half a wave, you're going to be having destructive interference once you're done. If you can fit a whole wave in, that's good. And that's where you get different colours, because different waves are different sizes, and different sizes fit in different things when they're going in and out. I don't know why you're laughing, I am talking about optics! I think there was oh yes, there was another joke, sorry, I forgot a joke. So, let's go back. Back. This starling is a splendid starling. It's his actual name. And I think all the other birds just didn't know that you could append a complementary adjective to your name. But now they have learnt that, we're going to be having rampant robins and tremendous tits and heavenly ham. So remember that, there will be a test. This butterfly is beige. You're very trusting, because it doesn't look beige. But in fact, it is only blue because only blue light is allowed to reflect from it because of the tiny, tiny structures in the butterfly's wings. So if you were to put this butterfly in a blender You'd get beige and blood and people going, why you put that butterfly in a blender? I'm never taking you to tropical paradise again. But this butterfly is blue because of physics. So we have these structures, which are like the layers we had before, but it has more of them, stacked on top of each other, and they're just in one line. So the only light that can get in and out and still be synced up at the end is blue. Only blue's the right size to fit in there. And that is how physicists like to do structure, like to do colour. You've got everything lined up, you don't do any messing around with pigments, you don't get yourself messy or dirty, you just have these beautiful, elegant structures. This is called a brag stack. And like many stacks that penis owners like to brag about, it's not actually that big. It's like 1/1000 of a millimetre. This green butterfly. Can you ask? Brag stacks, they're one-dimensional. Could you do it in another dimension? With voyeuristic intentions? Could you do it in 2 dimensions? Could you do it in 3 dimensions? And yes, you could, because this is Calliferous rubi, ruby with an I, and she's got these tiny structures in her wings that make her green because they repeat in 3 dimensions. And is the video going to work?
If we click on it. I knew you got to wait, there's a lag.
There! You are flying through the nanostructures on a butterfly's wings on a Thursday night. And her genus name, Calliferous, it means beautiful eyebrows. She is my animal role model. But we ain't birds. We ain't butterflies. We ain't nothing but mammals. So let's do it like they do on the Discovery Channel. Let's discuss genitals in embarrassing levels of detail. Oh, but I forgot a thing. You, sir, come and assist me with my thing. There isn't actually a thing, I just wanted to talk to him. Could you assist me with removing my sample? Which one? The best one. Would you remove the sample from the tube? And can we have the lights white, please? Can you tip it on your hand and tell us what colour it is? Not on that side, on the coloured side. No, this is science. There's a reason I've been training.
It's like silver.
It's more sort of greeny, shiny, I would say. But you know, colours and tastes. But it is greeny, shiny. And yet, when we drop it in the glass, it will change if we get it wet. So please, as it changes, it will be like the Bragg stack, and it will swell so that a different wavelength of light fits in there, and it will change from what you saw earlier. Take it back to you with your seat with you. Stare at the colours, pass them round, and initially it was green. Afterwards, it will be orange, and we think this is protective coloration from the beetle to avoid being mistaken for an olive in case it ever falls into a martini. Now, what am I talking about? Oh yes, genitals. So I said on your programme that they were going to be given bollocks, and I'm sorry, that was a lie. I got overexcited by finding an excuse to talk about balls in science. Physics, I work in physics. This is a blue scrotum, and you will not be surprised to learn that the colour comes from structure. Yay! Structural colour! These lines... Oh, fuck. Sorry. These lines mark where the light reflects off, and only blue light fits into these gaps, continuing the theme, and therefore the scrotum is blue. And biologists have proved this by injecting this scrotum with water. And then the gaps between them get bigger, and the scrotum no longer looks blue, it's white. Which is a fascinating fact, and kind of tells you what sort of people biologists are. And this scrotum is used to communicate status. The colour and hue of the scrotum communicates the status. And there is actually a thing where you'll note they have a red penis and a white belly. And they do a thing where they walk around showing off the white belly with the tail raised so that you can see the little blue scrotum. and then the red penis sort of bobs up and down. And this is called the red, white and blue display. It's actually the origin of Theresa May's plans for Brexit. She's just waiting for her custom dildo to be delivered, and then she's going to use that to get Britain all of its desired outcomes in Brussels. So what have we learnt? We have learnt that If you take something and you look at it from the right angle, you can have whatever damn colour you want.
Yeah!
But sometimes interference can be constructive. But you can append whatever complimentary adjective you damn want to the start of your name. But if you're going to enter some kind of international dispute, you should always make sure you have the correctly coloured sex toys. And if whatever happens, just throw the right shapes and you can come off any damn way you like. I am the fabulous Chromatik, and I will see you later. I would like my beetle back, thank you.